Wavelength and frequency of an electromagnetic wave is associated with what we perceive as the color of the light. Okay, and so the kind of wavelengths that our eyes can actually detect are known as, would be called visible light, would have wavelengths in the range of 400 to 800 nanometers. Okay, so for example, as I've mentioned earlier, around 500 nanometers right there, your eyes would perceive that color as green. So the red end, we say, of that visible spectrum, okay, this range of wavelength is called your visible spectrum. Range correspond to colors you perceive as red, orange, yellow, green, blue, and violet. So Roy G. Biv going that way. Okay. Um, so 400 to 800 nanometers. 1 nanometer being 10 to the negative 9 meters. Now, most electromagnetic radiation is actually invisible to us. If it hits your eye, you're not going to know it did until you go blind from too much exposure, maybe. But most electromagnetic radiation is invisible to us. So wavelengths that are shorter than violet are known as ultraviolet, and even shorter than ultraviolet radiation, you have what are known as X-rays, and even shorter than X-rays, you're going to have gamma rays. Okay. Beyond the red end of your visible spectrum, you have the infrared radiation. Longer wavelengths for the even longer wavelengths compared to infrared radiation would be microwave radiation, and then even longer wavelengths would be classified as radio waves. So these are what you would call regions of what's known as your electromagnetic spectrum, the range of possible wavelengths. So the shortest wavelengths would be X-rays, and then gamma rays and X-rays, and then ultraviolet, and then your visible region. And then you have the infrared region, microwave region, and radio wave region. Okay? Now, since frequency is c over lambda, you'll notice that the longer the wavelength, okay, the lower the frequency. So going from left to right here, your X-rays would have the highest frequency, gamma rays and X-rays would have the highest frequencies, and your radio waves would have the lowest frequencies. So let's look at some examples. Which color of light corresponds to longer wavelength, red or blue? Well, the red end of your electromagnetic spectrum would be longer wavelength. The violet end, where blue is closer to, would be on the shorter end of your wavelength scale. So red would have longer wavelength. Which color corresponds to higher frequency? Well, the shorter wavelength, right? So that would be the blue color. Which type of electromagnetic radiation corresponds to longer wavelength, microwave or X-rays? This is longer. Okay, so microwave would have longer wavelengths.